Welcome to qnawire.
All right, question 91 is asking us about the molecule for acetone. And the formula for acetone is CH3 2CO. Question part A says to draw the Lewis structure for acetone and predict the geometry at each carbon. So acetone, it has a double bonded oxygen to the central carbon with two unshared pairs on it, and carbon coming off of each side with the three hydrogens, that's the CH3 coming off of off the central atom. So there is our Lewis structure for acetone. That one refers to this structure right here, the carbon with the double bonded oxygen and carbons on each side of that. Then we want the geometry at each carbon. So the central carbon here has 3 electron clouds around it. The bonds are electron clouds, and this double bond counts as 1 electron cloud. So there are 3 electron clouds, or 3 electron domains, you might hear it said, around the central atom. Therefore, the central carbon with its 3 electron domains is going to have a shape of trigonal planar. And then the outer carbons, the peripheral ones, the ones with the CH3 on them, okay, those carbons have 1, 2, 3, 4 electron clouds around each of them. Therefore, they are going to be tetrahedral. And that answers part A. Part B says the acetone molecule polar or nonpolar. This oxygen in the middle here, this part right here, is going to make this molecule very polar. That oxygen has a high electronegativity, and we're going to create, having this oxygen in the middle of the molecule like this, we're going to create a significant dipole. Therefore, this molecule is very definitely a polar molecule. Part C, we want to know what types of intermolecular forces acetone molecules have between them. Well, first off, everything has London dispersion. All molecules have London dispersion forces, so we will definitely have LDFs. And then because this is a polar molecule, there are also dipole-dipole interactions happening. So those are 2 intermolecular forces that will occur between acetone molecules. Finally, part D says that 1-propanol, so the formula for 1-propanol is CH3, CH2, CH2OH. That 1-propanol has a molecular weight similar to acetone. However, the 1-propanol boils, its boiling point is at 97.2 degrees Celsius, where acetone's boiling point, I'm going to put that up here, its boiling point is at 56.5 degrees Celsius. And so why does the 1-propanol have so much higher of a boiling point? And the answer has to do with intermolecular forces. In order to boil, you have to break the intermolecular forces that are holding the molecules together as a liquid. And the stronger or more types of intermolecular forces you have, the higher the boiling point will be, the more energy it will take to break apart those molecules. And while the acetone only has London dispersion and dipole-dipole, the propanol has an added intermolecular force, a fairly strong one, and that is because we have this hydrogen here bonded to an oxygen. We can also have hydrogen bonding with the 1-propanol. And hydrogen bonding is a strong type of intermolecular force between molecules. Therefore, these molecules are going to be held together more tightly. It's going to take more energy to break those intermolecular forces. Therefore, it has the higher boiling point.